Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Okay, so today we will continue with chapter 3, part 3. Okay, so this is the final part for chapter 3. So today actually we will cover on the application of angle modulation, which is the FM stereo. And then we will also cover on the power measurement. Okay, so how to calculate for the total power in an angle modulation. And lastly, we will look into the advantages and disadvantages of angle modulation compared to amplitude modulation. Okay, actually I am planning to discuss on your midterm test today after the lecture. However, I cannot open the answer scheme on my laptop right now, but later I will check again. So if I can open it on my laptop today, then we will discuss on your midterm test today. Okay, so if not, we need to discuss after your mid semester break lah. Okay. So for chapter 3, part 3, so the first subchapter 3.11 is on the angle modulation application. Okay, so where this angle modulation is used. So I'm sure that you all know what is FM stereo. Okay, so if you have a radio, okay, so I'm sure that you know what is stereo, FM stereo means. Okay, so as a start, this one. Okay, this is a history of the FM stereo itself. Okay, so until the year 1961, all commercial FM transmission were monophonic. Okay, were monophonic transmission. So what is monophonic transmission? Is that it uses only a single 50 Hz to 15 kHz audio channel, which made up the entire voice and music information spectrum. Okay, so you only use single audio channel. Okay, so that is why we call it as monophonic. Mono is single. Okay, mono is one. So the single audio channel modulated a carrier and was transmitted through a 200 kHz bandwidth FM channel. Okay, so what is monophonic actually means? So in mono transmission, you know that for radio you have two speaker. Okay, left speaker and right speaker. Okay, so biasanya ada dua speaker for radio. Okay, so for monophonic transmission, each speaker, the left and right, okay, it produces exactly the same information. It produces the same sound signal. Okay, so for example, the entire information signal sound as though it's coming from the same direction. Okay, so the sound from the left speaker and the sound from the right speaker is exactly the same. Okay, there is no directivity. But starting from 1961, okay, so the Federal Communication Commission, which is the FCC, has come out with a stereophonic transmission. Okay, so this is what we call as FM stereo. So what is the difference between stereophonic and monophonic? Is that for stereo transmission, the signal is now divided into two. Okay, so the signal from 50 Hz to 15 kHz now divided into two. So we have one at the left and one at the right speaker. Okay, so you can see that for FM stereo, the music originated on the left side is reproduced on the left speaker, and the music that is reproduced on the hand side will be reproduced on the right speaker. Okay, so therefore it is possible to reproduce music with unique directivity and spatial dimension. Okay, so that is why nowadays if you listen to the music from your radio, you can see that there's actually a difference. The sound is different from the left speaker compared to the right speaker. Okay, so this is what we call as FM stereo. Okay, so this figure over here shows the FM baseband spectrum. Figure A is prior to 1955. Figure B is prior to 1961, and lastly, figure C is since 1961. So you can see that over here, before 1955, okay, so the signal transmission for radio, we use monophonic. So you can see that you only have a single channel from 50 Hertz to 15 kilohertz. Okay, and then prior to 1961, you still using the monophonic transmission. Okay, still using the monophonic transmission because you only have one channel, but there is another channel which is called as the Sca Channel Sub Carrier. So this Sca Channel Sub Carrier is the function is to broadcast music to private subscribers. Okay, so this one is for private subscribers only. But the thing is, prior to 1955 and also prior to 1961, we still use monophonic transmission. Okay. So, and then since 1961 and onwards until now, so we are changing to stereophonic transmission. Okay, so you get here, for stereophonic transmission, you have the left plus right stereo channel, and also the left plus right left plus inverted right stereo channel. Okay, so you the signal is now divided into two. So you have the left plus right, and also the left plus inverted right over here. Okay, and still we also have the Sca channel, which the function as the to broadcast music to private subscribers. Okay, so this two is monophonic transmission. This one is stereophonic transmission. Okay. So now let's look at the stereophonic transmission or the FM stereo spectrum. Okay, so this is the FM stereo spectrum. So you can see that it comprises the 50 to 15 kilohertz stereo channel plus an additional stereo channel frequency division multiplex FDM, and also this one, and also the Sca channel. So you can see that we have the left plus the right audio channel. So this is the left plus right audio channel. This is the left plus inverted right audio channel. Okay, and we also have the Sca channel. So the left plus right stereo channel, this one occupies from 50 to 15 kilohertz. Okay, and how do we get the left plus inverted right? Is when we actually modulates a 38 kilohertz subcarrier, and then it will produce a stereo channel occupying between 23K until 53K. Okay, so ni theory it doesn't involve any calculation at all. So this is just the application of where the angle modulation is used. So actually you don't need to go into detail. Okay, how do you get this value and so on. Okay, and the last one, the last channel, we have the Sca channel. So I already explained this before. The function is used to broadcast music to private subscribers. Okay, and the frequency is from 60 kilohertz until 74 kilohertz. Okay, so you can see that identical information is contained in the left plus right and the left plus inverted right, except for their phase. Okay, so everything is the same, but the difference is their phase. Okay, so it is not exactly the same. Okay, it's similar but it's not same. So now let's look at the FM stereo transmission. So remember, I've told you just now that for FM stereo we have left and also the right. Okay, so the signal that is generated at the left, okay, will be reproduced on the left speaker, and the signal from the right, okay, will be reproduced at the right speaker. Okay, so this is the block diagram for a stereo FM transmitter. So if you get here, we have, this is the left and right audio channels. Okay, this is the left plus right plus and left plus inverted right audio channels. Okay, and finally we have the final output that will go to the antenna of the FM transmitter. Okay, so basically this is the process for FM stereo. Okay, so you have the L input, the left input, the right input, and then later on it will then be combined. Okay, for transmission process. Okay, so this one I don't think you don't have to go into detail, because this one is actually not covered in your final. Okay, so I just want to show you the application of angle modulation, and one of it is the FM stereo, and in general how the FM stereo works. Okay, so it is actually a combination from the left input and the signal from the right input, and then it will be combined together by the linear combining network. Okay, and then this is the FM stereo transmission. Now let's look at the reception. Okay, so for the reception, this is the block diagram for the FM stereo reception. Okay, so this one, you can see that this is the comparison between monophonic and stereophonic. So this one, you can see that you only have one speaker. So this is monophonic. So this one, you have two speakers, one for the left speaker and the other one is the right speaker. So this is the stereophonic. Okay, so the signal that received from the FM transmitter will then receive by the FM receiver. Okay, so it will then go through this one for the monophonic. It will directly go to the de-emphasis network. So what is the function of the emphasis network? So please refer back to your slide. Okay, so I already explained this before in chapter 3 part 2, if I'm not mistaken. Okay, for the stereophonic, you need to go through a filter. Okay, first before it will then be separated into the left speaker and also the right speaker. Okay, so this is the process of the FM stereo reception in general. Okay, so how from a single signal it divided into two signals, left and right. Okay, so next let's look into the power measurement. So how can we calculate for the total power in an angle modulated wave? Okay, so remember for angle modulated wave, you have the power frequency spectrum, you will have something like this. Okay, so the number of side frequencies can reach up to infinite, depends on your modulation index or your modulation coefficient. Okay, so over here you have this is P0, P1, P2, P3. Okay, for example. So to calculate for the P total, okay, so you must use the formula. This is the formula for each of the sideband. Okay, so for example, if you want to calculate for P1, you need to use this one, 2 multiply V1 squared over 2R. Okay, so why you need to multiply with 2? Can you see over here? This one multiplied with 2, this one multiplied with 2, this one multiplied with 2, and this one is also multiplied with 2. Whereas in this equation, it is only VC squared over 2R. Okay, so this one, it is multiplied with 2 because you can see that this is a pair of sideband. Okay, so this is P1, P1. Sorry, not P1, P1. Okay. P1 is the power for sideband 1. Okay, so since you have the sideband consists of the left and right, okay, the upper side frequency and the lower side frequency, then that is why you need to multiply with 2. Okay, same for the others. For P2, P3 until Pn. So you need to multiply with 2. Okay, except for P0. So P0 is the carrier power over here. This is the carrier power, carrier signal. So the carrier signal, carrier power, it is Vc squared over 2R. So this one, you don't need to multiply with 2. Okay. So if you just add this, so you will get the answer for the P total for the angle modulated wave. Okay, so the thing is you need to know the value for V1, V2, V3 and so on lah, before you can calculate for P1, P2, P3 and also the P total. So this one is the side frequency. This is the carrier signal. Okay, any question? So if no question, we proceed with the final part in chapter 3, which is a comparison between angle modulated wave and amplitude modulated wave. So if you look at here, the advantages of angle modulated wave is that it is better in terms of noise immunity. Okay, why angle modulated wave is better in terms of noise immunity? Because in FM and also PM we have the limiters. Okay, so the limiters, the function is to remove most of the amplitude variation exists in the modulated signal. Okay, amplitude variation. Okay, so when you ask why angle modulation has better noise immunity compared to, why angle modulation has better noise immunity compared to angle modulation, you must answer this in detail. Okay, so you must be able to answer that angle modulation includes a limiter. So where the limiters, the function is to remove the amplitude variation in the modulated wave. Okay, so and for angle modulation, you can see that over here. For angle modulation, you cannot add in limiters. Why? Because the limiters, the function is to reduce amplitude variation. Okay, it reduce amplitude variation. But for amplitude modulation, most of the information contained in the amplitude variation. Therefore, you cannot actually filter or remove the amplitude variation in an amplitude modulation. Okay, so that is why angle modulation has better noise immunity compared to amplitude modulation. Okay, so and the second one, okay, so the first one and the second one, you can see that there's a relation to each other. So this one is noise immunity. This is noise performance and signal to noise improvement. So actually by right, you should know that since angle modulation has better noise immunity, therefore it also have better noise performance and signal to noise ratio improvement or higher signal to noise ratio in the system. Okay, so the higher signal to noise ratio actually means that there's less noise in the signal. Okay, so with the use of limiters, FM, PM actually reduce the noise level and improve the signal to noise ratio. Okay, and the third one is the capture effect. So in angle modulation, doesn't matter whether it is FM or PM, we have the phenomena of capture effect. So what is capture effect? It allows the receiver to differentiate between two signals received with the same frequency by capturing the stronger signal and eliminate the weaker one. Okay, so it only captures the strong signal and eliminates the weaker one. But in amplitude modulation, you cannot eliminate one of the signal, meaning you cannot eliminate the weaker signal. Okay, so amplitude modulation, it will actually, even though you have two signals received the same frequency, the amplitude modulation will demodulate both signal and produce the audio signal. Okay, and lastly, the advantages of angle modulation is in terms of power. Okay, power utilization and efficiency. So basically for the angle modulation, the power is taken from the carrier with modulation and redistributed in the sideband. Okay, so by right, this one, you have your frequency spectrum. Okay, so for angle modulation, the power is taken from the carrier with modulation and it will be redistributed in the sideband. Okay, so therefore the angle modulation, the total power remains constant regardless if the modulation is presented or not. Okay, so you can see that the power over here, this one, the power is redistributed in its sidebands. Okay, so these are the advantages of angle modulation. However, angle modulation still have its own disadvantages. Okay, so the main one is in terms of bandwidth. So you can see that, remember, for angle modulation, you can have up to infinite number of sidebands. Okay, it could reach up to infinite. Okay, so therefore you can see that in angle modulation, okay, the bandwidth tends to be higher compared to amplitude modulation. Okay, so high quality angle modulation produces many side frequency, thus it requires a much wider bandwidth compared to amplitude modulation. And another one disadvantages is that in terms of circuit complexity and cost. Okay, so basically, of course, angle modulation, the circuit is much complex. Okay, complex to design, and also much more expensive compared to the amplitude modulation. But however, since nowadays we have already have inexpensive large-scale integration ICs, therefore the price, the cost of the amplitude modulation and also the angle modulation currently is quite comparable to each other. Okay, so the cost is not much different nowadays. So any question for chapter 3? Any question for chapter 3?
No.
Okay. Saya tak boleh buka test ni. Ya. Okay, so actually we have finished chapter 3. So I've uploaded the tutorial for chapter 3. So I hope that this week plus the week during your mid-semester break, you can try to do the tutorial 3. Okay, so midterm test susah ke? Susah ke senang? I haven't checked your midterm test yet. Boleh jawab? Boleh lah.
Boleh tahan lah.
Boleh.
Boleh tahan tu boleh tahan susah ke boleh tahan senang?
So-so.
Saya tahan susah.
Susah? Okay, saya.
Tengah-tengah.
Apa yang susah? I think the question is straightforward.